Hello and welcome back. So this video is for class 9 and today we will start with the chapter Gravitation. Now already in a previous Google Meet video I have started this chapter. Okay, we discussed the Newton's law of gravitation. Today once again I will cover that topic and we will also see the concept of free fall. Okay, so let's begin. So first let us see the Newton's law of gravitation. Now obviously gravitation is not a new word for us. We have heard that word many times and I think everybody would be knowing that all of us are able to remain on the earth because there is a force of gravitation. Okay, and definitely you must have heard the story of Isaac Newton. The story is that he was sitting under a apple tree and he saw the apple falling down. Okay, and Newton thought why the apple is always falling down and not going up or to the right or to the left. Okay, and then that is when he discovered that there must be some kind of force that the earth is putting on the apple. Okay, so because of the force of the earth, the apple always falls down. Okay, or any object on the earth, it always tends to fall downwards. And that is when Newton discovered the law of gravitation. Okay, so let us see what is this universal law of gravitation. So let us imagine there are two objects, mass m1 and mass m2. They are separated by some distance, let us say d. Okay, these are two objects which are in space. So according to Newton's law of gravitation, there will be an attractive force between these two objects. Okay, so what the Newton's law of gravitation states, that for any two masses separated by some distance, there will be a force of attraction. Okay, that force is known as the gravitational force, and according to Newton's law, this force is directly proportional to the product of the masses, that is m1 multiplied by m2, and inversely proportional to the square of distance between them. So we will get F proportional to m1 m2 by d square. Okay, so this is the Newton's law of gravitation. Now we have a proportionality sign. To remove that we will add a constant. So we get F equal to, the constant we add is capital G. Capital G m1 m2 by d square. So this is the statement of the Newton's law of gravitation. This G is called as the universal constant of gravitation. Okay, and experimentally we have found that G is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, so that is the value of G. Now of course you may be asking, how do we figure out? There are number of experiments that we can perform to find out, but again for our level that will be very difficult. Okay, when you reach higher classes we will actually discuss how this G can actually be calculated. But anyways, for now you have to accept that the value of G is 6.67 into 10 to the power minus 11, and the force of gravitation is given by F equal to G m1 m2 by d square. Using this formula you can find out gravitational force between any two objects. So the thing to remember is the gravitational force is not restricted for our earth. Okay, it is not that only our earth is having the gravitational force. According to Newton's law, any two masses will exert a force on each other. That is called as the gravitational force. So it is because of the gravitational force that all the planets, they are revolving around the sun. It is because of gravitational force that moon is revolving around the earth. Okay, so it is gravitational force that is actually present all over the universe, and that is why these are the phenomena that we are noticing. And of course, as we already discussed, you and I, we are remaining on the earth because of this force of gravitation that the earth is exerting on us. And now I'm sure you must be remembering Newton's third law. Third law is that to every action there is equal and opposite reaction. So what is the meaning of this? When the earth will exert a gravitation force on you, okay, at the same time you are also exerting a gravitation force on the earth. Okay, only thing, the force that we will be exerting will be opposite to the force of the earth. But remember, you are exerting exactly the same amount of force that the earth is exerting on you. Okay, that is the beauty of gravitation. Now let us talk about the concept of free fall. Okay, free fall is very easy to understand. If you take a stone in your hand and you let go, what will happen? The stone will start to fall down. When the stone is falling down, you will notice it is going in a straight line, correct? And it is moving down because of the Earth's gravitational force. The Earth is putting a gravitational force on that stone, and that is why it is falling down. This is called as the free fall. Okay, so when an object falls only due to the force of gravitation, that motion we call as a free fall. Okay, so when we jump out of an airplane, okay, that motion that we'll be calling as a free fall. Okay, or let us say the stone that we were talking about, or when rain falls down, so motion of the rain, that will also be a free fall. So when any object is falling only under the Earth's gravitational force, that motion we call as free fall. So let us consider an object having mass m. Okay, it is held at some height. If we let go of this object, what will happen? It will start to fall down, and we will say it is having a free fall. So let us say it is here at some point A, it falls down and reaches some point B. Okay, obviously you would know that when an object is falling down, the speed will go on increasing. Correct? You must have seen that. When you are trying to catch a ball, if it goes very high, by the time it is coming down, it is very difficult to catch it because the speed of the ball has increased. Right? So when you go from A to B, the speed increases. That means we have got some acceleration. Getting the idea? So when an object is having a free fall, it has some acceleration, and this acceleration is called as acceleration due to gravity. Right? Now why do we call it acceleration due to gravity? Because this object was having a free fall, that was motion only due to the gravitational force. Correct? And that is why this acceleration that the object is having in free fall, we term as acceleration due to gravity. Okay, and it is denoted by the symbol small g. Okay, now don't get confused between small g and capital G. Capital G was the universal constant of gravitation. Small g is the acceleration due to gravity. Okay, so I hope that both these concepts, that is the free fall and acceleration due to gravity, is understood. Okay, so that was the Newton's law of gravitation and the concept of free fall. Make a note of both these topics. In the next class, we will try to find out a formula for this acceleration due to gravity, and we'll also see some numericals based on these. Okay, now if there are any more doubts, make sure that you are asking me. So that's all for today. Thank you.